purpose of this video is to give you the answers to the Module 2 assignment. In question 1, it's asking you to state the group number of P. If we look at a periodic table, the group numbers are written across the top here. If they're not written, then you can just write them in as 1, 2, and then over to here 3, 4, and 5. Group numbers match the number of valence electrons. Phosphorus is in group 5, so that's the answer to that one, is P is in group 5. State the period number for Ca. Period number is going to be the row. So this is 1, 2, 3, 4. Calcium is in period 4. This also matches the number of energy levels, and that's the next question. Next question is asking about the energy levels for Sr, and if we look at where Sr is, it's down here, and it's 1, 2, 3, 4, 5. So the number of energy levels in Sr is going to be 5. Number of valence electrons, as I said earlier, the group number matches the number of valence electrons. Potassium is in group 1, so it has 1 valence electron. Copper is a metal. Which one of these is true of copper? The properties of metals are ductile and malleable, also conduct heat and electricity. And in this case we can see that copper would be ductile. It would not malleable would be not true for a metal. Brittle is something that's usually true of non-metals. For the next 3 questions, the electronegativity, ionization energy, and size, I would encourage you to look at the Module 2 soft chalk, and you will find that on page 8, starting on page 8, you can see the electronegativity, then the ionization energy, and then the size are all discussed, and you can use this as a guide to figuring out these kinds of differences that are being asked in this question. So it says for this one, order the following from most electronegative to least electronegative. Sorry, from least electronegative to most electronegative. Least electronegative will be 1, most electronegative will be 3. According to the information we have here, fluorine is the most electronegative element, francium is the least. The elements we're working with are potassium, copper, and bromine. Bromine will be the most electronegative out of those 3, followed by copper, followed by potassium, and that will be reflected in our answer right here. Least electronegative will be potassium, copper be next, and then most electronegative would be bromine. Make sure you read these carefully, the 1 and the 3. Order the following from lowest ionization energy to highest ionization energy. Again, look at the Module 2 soft chalk, and the ionization energies, this will be the lowest down here, and helium would be the highest up here. And in this row, potassium, copper, and bromine. Bromine will have the highest ionization energy, followed by copper, followed by potassium. To give us our answer here, it said lowest to highest. Lowest will be potassium, highest will be bromine, copper will be in the middle. The size, this one is a bit odd because you might think that it would go the opposite way to what we actually think it does. It's pretty obvious that with size that the largest in a column would be the ones at the bottom, followed by by each as we go up the column to the smallest up the top of the column. But going across, it actually does what we don't expect it to do. As the atoms get larger across the row, as the number of protons and electrons increases, the size actually decreases. Now the reasoning for this is sort of linked to electronegativity, and the fact that as we add protons to each of these elements going across the row, it pulls in the electrons just that little bit more. So the atomic radius generally tends to decrease as we go across the row, which is not really what we expect. So in the group that we're talking about, potassium would be the largest, followed by copper, followed by bromine, and that would be reflected in the answer as well. And you can see that going from smallest to largest, smallest will be bromine, followed by copper, followed by potassium. Remember, look at smallest 1 to largest 3. Make sure you take notes on the 1 and the 3. K plus is smaller than K. Generally what we say is that when we have positive ions, we've lost electrons, so those tend to be smaller than the atoms that they came from. When we have negative ions, those tend to be larger. because we've added electrons. In this case, K plus is smaller than K. That would be a true statement. Now question 10, how many H atoms are present in FeOH3? The parentheses indicate we have 3 OH groups, and that means we've got 3 hydrogens, and that means that our answer is going to be 3 H atoms. For the next part, where we're talking about electronegativities and the relationship between bonding, I strongly recommend that you read the soft chalk here, starting on page 12. And you can see that I do have a table here that links the kind of bonding to difference in electronegativity. I've also got some diagrams here to kind of explain why we have certain kinds of bonding for certain differences in electronegativity. But the other thing I can also tell you is that there's a link, and if we look at the question here, we've got sodium and oxygen. There's also a link between where things are on the periodic table and the differences in electronegativity. And what we find is that these kinds of metals over here have low electronegativities, while non-metals tend to have higher electronegativities. And what that will mean is that these are going to have large differences between them when there's a fairly large distance between them on the periodic table. And as I can show you here, that's usually going to be indicative of an ionic type bond when you've got large differences in electronegativity. And again, I would really want you to read through this and get a good understanding of why we have different kinds of bonding for different differences in electronegativity. In this case, we've got oxygen and oxygen. O is 3.9. The bond will be non-polar covalent. That's because, again, the electrons are going to be smack dab in the middle of the O and the O, which would mean it's a non-polar covalent bond. But again, read through the page here to get a good idea of why we have different kinds of bonding for different differences in electronegativity. The last one here has to do with heat capacities, and the question here is energy is applied in the amount of 0.385 joules. A joule is just a unit of energy, and it's applied to 1 gram of copper, and we're given a heat capacity, and 1 gram of silica, and again we're given a heat capacity for that. And the question is, which will show a greater increase in temperature? Well, if the heat capacity of copper is 0.385 joules per gram per degree Celsius, what that means is that's the amount of energy, 0.385 joules, it takes to raise 1 gram 1 degree Celsius. So if I apply 0.385 joules to 1 gram of copper, it makes sense that it goes up by 1 degree Celsius, because this is 0.385 joules per 1 gram per 1 degree Celsius. If we do the same to silica, silica has a heat capacity of 0.703 joules per 1 gram per 1 degree Celsius, which means that if I add 0.385 joules to 1 gram of silica, it's not going to raise it by 1 degree. 0.703 joules is required to raise it by 1 degree. So if I put 0.385 joules into 1 gram of silica, what's going to happen is it's probably only going to raise it by about half a degree. That would mean the answer to this one would be copper. That would have the greater increase in temperature, 1 degree versus about half a degree for sand.